Hello everyone, welcome to our pre-calculus pre-recording video. This is our lesson 1, a brief introduction to trigonometry. So we will start from the basic of trigonometry, then we will enter into our lesson in this video. First of all, trigonometry. What is trigonometry? What it does? This kind of questions. If you look at this, trigonometry basically deals with the thing like triangle and then angle, this kind of thing. You see, the word trigonometry actually comes trigono, which is related to the triangle, and metry, which is related to the measurement. So initially, although trigonometry used to work with the triangle mainly, but later the circles and the study of the function of angle started coming to put a big role in trigonometry. And the history of trigonometry is, back in 3rd century BCE, we have the evidence that they used to use the trigonometry. But even before that, Egyptian and Babylonian civilizations, they also may have had some idea about this trigonometry because because of their mathematics calculations related to the pyramid and other things. This kind of calculation indicates that they used to have some sense of trigonometrical basic concept, but we do not have the evidence of rigorous use of that. Where do we use trigonometry? We use trigonometry in finding the distance in the navigation, in the astronomy, engineering. Even this picture is related to the astrophysics, astronomy, and astronomy related. Back in the ancient days, actually, the mathematicians tried to analyze the sky and the objects that they have seen in their naked eyes in the sky. So they used to try to do some calculation related to the relative position of that bright objects in the sky. Then actually this kind of calculations started evolving, and then now we have their much developed version of it. This is actually a picture where relative position of sun, earth, and moon uh, is given here. Okay, and describing the behavior of the waves. Now, since it deals with the angles, so waves and other things is related to that thing. So we can actually analyze it: sound wave, light wave, this kind of wave. Also, we can describe by using the trigonometry. So trigonometry helps us actually in many ways here. In the history of the trigonometry, we can add a few more sentences here because later from the Greek, after the Greek, then later some people in the Indian subcontinent, they started working on the trigonometry. Then the Arabian mathematicians, they also contributed to it. Later, again, the European people nowadays, after the Renaissance and other thing, they actually started developing it pretty in the modern state. But this actually have a wide range of history in the development of trigonometry. So let's look at now in the some very basic things related to the triangle. So what you see when you see the triangle? How do we find out the area of the triangle? Area of the triangle. How do we find it? When you have the base and height, you just we can write half into base into height. Then that gives us the area of the triangle, right? And that's because actually you can relate it with the square also. So if you have this is not a square, this is rectangle. Since one side is larger, that's why. So if we have this kind of rectangle, the length of the rectangle, let's say L, then the width is, let's say, W. So the area of this rectangle is length into width. But you see, if we draw a line through the one diagonal to another diagonal, yep, that's a line. One diagonal to another diagonal, actually, that's two triangles. That's two triangles. So one triangle is here and the triangle is here. So the area of the triangle will be just half of this value. So half into length into width. So basically this is the same concept here. And another half is, you can write here, the area of this part is half into length into width, total is length into width. So this way we can actually connect one part to another part. And so half into base into height, the area of the triangle, and the sum of all angles inside a triangle is 360 degree. This one is 90 degree, and this one is total 90 degree, so total is 180 degree. But for a rectangle it is 360 degree. This is 90 when it is a right angle triangle, then this one plus this one, total is 180 degree. So the sum of all angles of a triangle is 180 degree. In this triangle, so you see there is two triangles here. We have to consider it that way. Let's take another color. This one and this one. So this is 90, and this one plus this one is 90. And if we can look at this side, so this one is 90, and then this and this will together will be 90. Total is 180. Total is 180. Again, this is interesting for a triangle. If you just look at this one, and this one, then it will be 180. No matter how you draw a triangle, sum of all angles will be 180 always, regardless of how you draw it. Always sum of all angles. This line has to be perfectly straight, not curved. Then it will be always 180. So angles inside a triangle is always 180 degree. This is the Pythagorean theorem. Just to recap, when you have a right angle triangle, this is the hypotenuse. So hypotenuse is square equals to sum of other two sides is square. That means a square plus b square. Pythagorean theorem. Very useful theorem in mathematics. In many places we always use this Pythagorean theorem for our calculations, and in particular, if the angle is not given, this angle is not given, we only know that this is 90 degree, then any two sides are given, we can use the Pythagorean theorem to find out the other sides. So if the angle is not given, then Pythagorean theorem helps. Now if the angle is given, what about that? So say you know that this is 90 degree and this angle is given. Then what about that? Then comes, we have the trigonometric ratio. Then trigonometry start playing its role. Okay, trigonometry starts playing its role. So we have here, this is hypotenuse, this is adjacent. Adjacent is always with this angle. Okay, if the angle is given here, then this is the adjacent. If the angle is given here, then this side will be adjacent. Hypotenuse is fixed. Hypotenuse is the other side of the right angle. This is the right angle. Opposite side of right angle is hypotenuse. This is always fixed. Then adjacent and opposite actually can change. If the angle is given here, already it is given here, then it is adjacent. But if the angle goes there, then this side will become the adjacent. Now you can say, sir, if both angle is given, then what I will do? In that case, you will have to choose on the basis of which angle you are trying to do the calculation in your maths. So if you start calculating on the basis of this angle, then this is adjacent. If you want to start your calculation on the basis of this angle, then your adjacent will be this one. What I mean by this, let me explain. Suppose this is 30 degree. So this is adjacent because you know this angle. But when you know this is 30 degree, you automatically know that this angle also, because this one and this one total will be 90. That means this is 60 degree. So you know this angle also. So when you know both of the angle, now decision is up to you, which angle you want to use. If you don't want to use this angle, then you want to use this angle. That means this is the adjacent now. You will have to consider this adjacent. This will become the opposite. So this is how the sides actually changes because of the position of the angle. Okay. And answer will be same. Don't worry about that. Answer will come same. Alright. So now let's develop the concept on the basis of this angle. If we have this is the angle, then this is the adjacent. Now you see we have three sides here: hypotenuse, adjacent, and opposite. So we can write hypotenuse by adjacent, adjacent by hypotenuse, hypotenuse by opposite, opposite by hypotenuse, opposite by adjacent, adjacent by opposite. In 6 different ways we can divide them. We can find their ratio, and then we give them some name. Opposite by hypotenuse, then let's call it sine theta. Adjacent by hypotenuse, let's call it cos theta. Opposite by adjacent, let's call it tan theta. And then we can take the reciprocal to call it, there is 3 other names, cosec, sec, and cot, the opposite of reciprocal of this. So from where this sine theta came? Sine theta is the ratio of opposite and hypotenuse, or opposite divided by hypotenuse is sine theta. This is the ratio of these sides. Ratio changes. You know, this line can be longer, this line can be longer. That's why they have some relationship actually. That ratio changes. This side becomes longer, then this will be longer. This side can be different, so side lengths can changes. Of course, with the side lengths, other thing also will adjust in a triangle, because we are trying to make a triangle. So let's come back to the point once again. The ratio between opposite and hypotenuse is sine, adjacent and hypotenuse is cos, and opposite divided by adjacent is tan. And there is a nice mnemonic for keeping it in mind. This is called SOHCAHTOA formula, SOH. SOHCAHTOA, TOA, SOHCAHTOA. To keep it in mind, to memorize it, this is the mnemonic. SOHCAHTOA. So means SOH. So that means sine equals to opposite by hypotenuse, cos equals to adjacent by hypotenuse, tan equals to opposite by adjacent. Okay, so that's why it is called SOHCAHTOA. SOHCAHTOA. This way you can keep it in mind. Now, as I said, the reciprocal of sine, cos, and tan is cosec, sec, and cot. So just if you just alter it, this is opposite by hypotenuse, then cosec will be hypotenuse by opposite. So by shifting this, we will get the other 3. Okay. So when the angle is given, then we can actually, and this is right angle. When the angle is given and the triangle is right angle triangle, then actually we can use this trigonometric ratio. You have to keep it in mind. This is important. When the angle is not given, then what? When the angle is not given, then Pythagorean theorem. This is a right angle triangle, but no angles are given, then Pythagorean theorem. Then if one angle is given, then you can use the trigonometric ratio, provided that this is a right angle triangle. Okay, this is an application where you can use it. Suppose this is a skyscraper's long building, large building, and then you have some distance here. You know the distance here, and you know this angle. That means adjacent value you know, the value of adjacent you know, and this is the height. Okay, this is the height. But we do not know the height, we only know the adjacent and the value of angle. Value of angle is 73 degree and 50 meter is this distance. So how can we find out how tall is the building? What is the height of this building? How can we find out? See, trigonometry can help actually in this case to find out the height. Without climbing, without going there, we can actually find out the height of this building if we know what is the angle from here to the top of this building. And now you can say, sir, to find out the angle we have to go there. Actually, we do not have to go there. There are mechanisms by which we can estimate it, like what is this angle can be. There are like instruments in the trigonometry. Let's say protractor and this kind of thing we can use. And set square, we can use that kind of things to accurately measure that or estimate that. So once you have these two things, angle is 73, this is 73, this is 50, What is the value of h? Try to find out, then we will show you here. So first thing is, why the tan theta is here. The reason is tan theta is related to adjacent and opposite. Tan theta formula is opposite divided by adjacent. That's why tan theta here. Yeah. Because this adjacent value is given, we have to find out the opposite. And if you go to this page, you see tan theta formula is opposite and adjacent related, but other two is hypotenuse related. So in this question there is no question for the hypotenuse. That's why we are using tan theta. Tan theta is for that reason. So tan 73, angle is 73, h we will have to find out, and x is given 50 meter in this case. Then you use in the calculator like tan 73 equals to what? Then h equals to what? We can easily find out. Tan 73 means 3.27. Then 50 into 37 means this meter. This is the answer. So this way we can apply the trigonometric ratio related knowledge. Now let's enter into another topic, which is called measuring the angles. We are touching actually a couple of things in this lesson. So when you have initial side, some angles, if you want to measure any angles, like how do we measure it? This angle, or let's say angle becomes bigger. How do we measure it? So first of all, we fix something. Let's say this is our starting side, initial side. Then we go from here to here. What is this angle? We use protractor and other things to measure it. This point is called vertex. Just to let you know, this is vertex, and this is the initial side. This is the terminal side, like this one. So this side will change. This side is here, then this side can go here, then angle is different, then this side go there, then angle is different, and always we will measure everything from this initial side. Okay, and notice that we are going anti-clockwise. This is the convention for positive angles. Angles are denoted by this alpha, beta, theta. They are Greek alphabet, Greek letter. So we can measure the angle like this. In the coordinate axis also we can do that. So one full rotation means 360 degree. Suppose if the line starts from here, let's go there. If the line starts from here, then line goes there, line goes here, this line goes here, then line comes here, line comes here. Then if the line comes back once again, then total is 360 degree, because you know this is 90 degree, 90 degree, 90 degree, 90 degree. So total is 360 degree. Okay. Now this is a circle, as you can see. Just giving you basic about this thing. And this outer layer of a circle is called the circumference. If a line goes through the center of the circle from one side to the another side of the circle, this is called diameter. And from the center to the circumference, this distance is called radius. So we can easily see that diameter is basically the double of radius, 1 and 2. That means 2 radius together is diameter. This is the circumference. So d equals to 2r. That's why it is said that. And the circumference is pi times the diameter. The length of the circumference is called 2 pi r. The total distance here is 2 pi r. This total distance is 2 pi r. 2 pi r. 2 pi r. So say r equal to 3, then you can write 2 into pi. Pi means 3.1416 like that. So 3.14 into 3. Then we get the total distance of this circumference. Let's suppose 3 centimeter, 3 meter, whatever this is. So this is how we can work with that. Measuring the angles using a circle. So same concept. This is the initial side, then it can move like that, like this and like this. So we have 5 degree, 2 degree, 10 degree, 90 degree total, then 180 degree, 270 degree, 360 degree. This way we can actually start measuring it. And we all are used to with this kind of measurement, like what is this length here, what is this angle, that angle, 90 degree, 180 degree, this kind of measurement. But there is another kind of measurement system which is called radians. We can measure the angle in radians also, and radian is pretty much straightforward, uh, which is if you have suppose 3 centimeter, suppose 2 centimeter, 3 centimeter, suppose 2 centimeter length from here to here. First, let me tell you 1 degree means what. 1 degree means this total thing is 360. Then you divide this whole space 360 times, divide it, then you get 1 degree. Small, very small part is 1 degree. Okay, so total is 360. You divide these things into 360 parts, then you get 1 degree. Now, look at this. This is, to understand this 1 degree, first of all, you must memorize that total is 360 degree. Now, suppose someone comes from outer space, some alien comes, then if you give that alien this circle and if you ask what is this, can you find out the angles, then he will not understand, they will not understand it, because they do not know that total is 360 degree. We are assuming, or we are saying that total is 360 degree. Okay, they do not know that, and if they do not know that, then they cannot find it out. So that 360 is the key here. The key is 360. The core is 360 total in this case. But for the radian, interesting thing about radian is you will not have to memorize anything for the radian. Suppose if it is 2 centimeter, and then you go 2 centimeter this way also in the curve, same 2 centimeter, you go here, then since this is a part of circle, so this will also be 2 centimeter. Then when you have this kind of thing, this is 2 cm here, 2 centimeter here. I'm just saying from where the radian came. Then this is also 2 centimeter. This is also 2 centimeter. This is curve. Then the angle subtended in the center here is called 1 radian. Now you can say, sir, now they have to memorize this is 2 centimeter. Actually, no. They can think about this is 1 centimeter, 1 centimeter, 1 centimeter. Then the angle will be 1 radian. They can consider this as 5 centimeter, 5 centimeter, 5 centimeter. Then the angle will be 1 radian. So basically, regardless of what is this length, just the condition is this length has to be same everywhere, then it will be 1 radian. Okay, then it will be 1 radian. Now say in our initial example, we said that this is 2 centimeter, 2 centimeter, 2 centimeter. Now say this is 2 fixed, then this goes another 2 centimeter here, just like a circle. Then it will be 2 radian, because 1 plus 1, 2 radian. This way the radian increases. Okay, this way the radian increases around these circles. And actually we have the nice little formula here to find out, and we can establish this also very easily. This is total is 360 degree. The total is 360 degree, and 360 degree is in the center here. When you go this 360 degree, basically you pass this entire circle. And if it is unit circle, if we consider it, let's go back. So from that concept, actually, just a while back we said that total is 2 pi r, and when r is 1, then basically we have that 2 pi when it is 1 unit, and then we get total distance covered here is 2 pi, and which subtend the angle 360 degree in the center. So we can consider 360 goes to 2 pi in a general term. Then 2 and this we can cancel out. Then we get actually pi radian equals to 180. Pi radian equals to 180. Pi radian equals to 180. Dividing both sides by 2. From where it came, total is 360 in the center, and when this goes 360, at that time it covers this entire distance, which is 2 pi r, and r value when it is 1, you can actually change this r value, but still the angle subtended here it will remain same. Okay, angle subtended here it will remain same. The ratio can increase, but at the same time it will keep it same in the center. Total angle in the center it will keep it same. So, and we have mechanism for that. If the radius is different, then how we have to adjust it, that is coming in the next slides. So 2 cancel out, then we get 180 equals to pi, and then pi equals to 180, then 1 equals to what we can find out. Then 1 for 1 radian it will become, 180 divided by pi. This side is radian. That means 180 degree equals to pi radian. So 1 degree equals to what? So 1 degree equals to pi divided by 180, which is this formula. And in the opposite way, we can say, okay, pi radian equals to 180 degrees, so 1 radian equals to what? Which will be 180 divided by pi degrees, vice versa. This is how we convert from degree to radian and radian to degree. This is the rule for conversion. And from where this formula came? This formula came from the main basic idea of this. 360 degree is equivalent to 2 pi radian, 2 pi radians. These are some standard values, commonly used values of sine, cosine, and tan. So like sine 30 degree equals to what? Sine 30 degree is 1 by 2 cosine. Suppose cosine 30 degree is what? This is root 3 by 2, etc., etc. In some future class, I will show you how this angle comes here, like how it becomes, or why it becomes 1 by 2, why it becomes root 3 by 2. But this is a standard model, kind of commonly used values. That's why we have this 0 degree, 30 degree, 45 degree, 60 degree, 90 degree, then 180 and 270. These are the very commonly used, because in most maths, in many maths, you will see all of the sudden this angle comes. That's why they are commonly used trigonometric functions. Okay. These are the values. Yeah. Okay, here it comes where we said that if the length of the radius is different, then how it works. The next slide it will come. So this is an interesting thing about this circle. You see, if one side increases in this triangle, then another side decreases. This side, see, this side is increasing, but the other side is decreasing. Okay, same thing is happening. This side increasing, but that side is decreasing. But the hypotenuse is same. Hypotenuse is same. So if you take this hypotenuse as 1, then actually it becomes unit circle, and it will always follow the x value whole square, and the y value whole square will always, it will become 1. What does it mean? When you have the radius 1 unit, this radius, this is x and this is y. So according to our, this is x and this is y. According to our Pythagorean theorem, what it says? It says this value is squared, x is squared plus y squared. This equals to this side is squared. This hypotenuse is squared, but hypotenuse is 1. Why it is 1? We considered that this circle is 1. The radius of the circle is 1. And if the radius of the circle is 1 unit, this is called unit circle. Unit circle means the radius is 1. Why we are taking all of a sudden 1 unit, radius 1? Because it is easy to understand. Then we can actually develop our idea from 1 unit to the many units. Suppose 2 unit, 5 unit, then what will happen? Which is easy, you will see. Not hard. So we can establish this x square and y square, it will always become 1, because if the triangle from here, if it goes there, suppose it goes here, it doesn't matter where it goes, it can go there. In that case, this is small, this is bigger, so together it will become that one again. Okay. Now you see, here we have one very important concept that we can develop here for our future classes. and you will see that. So this is one, we are sure about that. This is the x side of our coordinate system, and this is the y side of our coordinate system. So basically this point we consider it x comma y. This will not always be x comma y, this will be some number comma some number. Okay, now look at this, what we have learned from SOH formula. So SOH, SOH formula, what we have learned from there? Sine means sine equals to opposite divided by hypotenuse. So what is opposite here? Opposite is y. That means this equals to y divided by 1. Hypotenuse is 1 here. So we can write sine theta. See, this is very important. You will see all of a sudden we will get a formula now. That means sine theta equals to y, which means that this y value, whatever it is the sine theta for a unit circle. For a unit circle, this is main condition. It has to be unit circle. Then sine theta means y. Same way we can come from we can develop for cos theta. Cos theta equals to CAH, adjacent by hypotenuse. So adjacent is x. That means x divided by 1 equals to x. So that means this x value is our cos theta. That means cos theta value equal to whatever this number we have here. You will see we will do maths on this concept where number will come. Okay, that means cos theta is the x value on the unit circle. Okay, on the unit circle here some value will be given, some value will be given. Then first value will be cos theta equals to, second value will be sin theta equals to. This is what I am trying to say. And then tan theta is now I think you can easily understand tan theta. Tan theta is actually adjacent, opposite divided by adjacent. So opposite is y divided by x. So y divided by x. And from here actually we can develop the formula of y tan theta equals to sin theta divided by cos theta. You see, sin theta equals to y, cos theta equals to x. So that means tan theta equals to sin theta divided by cos theta. Sin theta divided by cos theta. So from here actually we can develop that formula also. Okay. This is a very important concept actually, and we can develop the other three also, because other sin theta reciprocal is cosec theta, CSC and or COSEC, both is correct. Cos theta reciprocal is sec theta, tan theta reciprocal is cot theta, and vice versa. So this is cos theta first one, second one is sin theta. So now if it is larger, then what will happen? Suppose if we said that if for a unit circle this is 1, okay, but not 1. Suppose if it is 2, then what will happen is, for instead of this is sin theta, instead of sin theta it will be 2 sin theta, because the length is now double. If it is 3, it will become 3. No complication. Okay, no additional complication here. If it is 3, then it will be 3. It will be 3. That's it. If the number becomes bigger, then it will become bigger of the same amount. But at this point, we will not complicate these things with different numbers. We will discuss about the unit circle first 1-2 classes here. So this is actually easy math relatively. So which one is sin theta, cos theta here? Which one is tan theta here? Which one is cot theta here? You will try to find out that. I think you can easily you will easily notice what is sin theta, what is cos theta, what is tan theta here. Is done here also. Yeah. Or we can try to solve these maths in our class also. Also, we will give this maths in our assignment also. Assignment means participation quiz in this case. So we can give this kind of maths in the participation quiz also, and we will discuss these maths in the class. We will solve this kind of maths more in the class also. These are the similar type of maths. So that's all for our first class. So we have discussed many concepts just for the basic development, but we will dig little deeper in the future classes. In the meantime, have a nice day and try to practice and read this chapter. This is 6.2. Okay, this is 6.2 in your book, and some of the concept came from 6.1 also, little bit. We mixed all these things that are necessary for developing the future lesson. All right, so thank you all. Thank you very much. Have a good day. See you all in the class. Bye.